Hey, what's going on? I think that we're live. I expected one thing to happen and it didn't just happen. So, okay, yeah, I think that we're going. Good. What's up? How's it going, YouTube? What's up? And then we should also start the YouTube Shorts inferior stream. Today we're going to be multi-streaming, which is a fancy power user trick I've learned as a streamer in the past. And it's so funny to me that that this math stream might be showing up in YouTube Shorts, because this thing is the opposite of a YouTube Short, if you ask me. But hey, it's a great way to find new users, quote unquote, audience members. So what's up? Hello. To that point, my name is John. I hope you enjoy this very much. I love it. I think it's a cool idea. This is a brand new channel. We're on day 7 at the moment. And today we're going to be working from a couple of linear algebra textbooks. So I am the Math Hobbyist. Brand new name. I think I created it yesterday. And I definitely created this new channel banner and profile avatar thing. So please let me know what you think. I am extremely open and receptive to feedback. In a sense, that is what this whole stream is about. Let's get feedback. Let's get an open discussion about mathematics, practice tips, and how to study effectively, how to pursue and cultivate like a deep hobby. You know what? I might be streaming to my guitar channel. Look at that. Okay, yeah, I messed something up. All right. Be right back. All right. Be right back in the YouTube short stream. That's funny. What's up? How's it going? Yeah, there's so many little fiddly knobs and settings that I have to set up as a streamer. It's insane. Okay, what's going on, YouTube Shorts? So we're trying one more time. Here is a mathematics stream. I was just accidentally streaming to the wrong YouTube channel, but now we're back, I think. Yep. Okay, everything is working correctly, I think. What's going on, everybody? I hope you're having a wonderful day. Today I'm trying to stream to YouTube Shorts vertically and to the regular YouTube horizontally. So maybe we can find some new viewers that way. My name is the Math Hobbyist. Here is my logo. I just created this yesterday. For those who don't know, this is a beautiful formula in math. This is Fermat's last theorem. Fermat's last theorem. Something that is amazing is a lot of people don't know Fermat was a hobbyist. He was a hobbyist just like me. I think that he was a lawyer, if I remember correctly, and he just did math on the side for fun. And so he had one of the most famous textbooks in math called Diophantus. Which is a textbook all about simple equations that use integers. So not even, we don't have pi, we don't have rational numbers. Well, Diophantus did do rational numbers, but mostly it was focused on integer solutions to equations. And this is one. It was known, and I think Fermat proved it himself, even as a hobbyist. I think he proved that there are no integer solutions to a cubed plus b cubed equals c cubed. Now that I think of it, I think I misspoke. I don't think he got a cubed. I think he got a to the fourth, b to the fourth equals c to the fourth. He proved that there are no integers other than 0. One of them has to be 0. You could have 0, 1, 1, for example, but you can't have all 3 of them greater than 0. Whereas, of course, the Pythagorean theorem, a squared plus b squared equals c squared, everybody knows that, and it has infinitely many solutions. 3, 4, 5, and 5, 12, 13 are two of the most well-known ones. But there are no solutions for the same equation with the fourth power. And for a very long time, it was speculated that there are no solutions anytime that n is greater than 2. But we didn't solve this problem until 1994, if I remember correctly. Definitely in the 90s. This was proved by somebody named Andrew Wiles. And for some fascinating flavor, back to Fermat. Back to Fermat, some fascinating flavor is that he actually said in his notebook, or in his copy of Diophantus, that really famous math textbook that he was working through as a hobbyist, just like us, he wrote, I have a beautiful proof for this. I have a beautiful proof, but it cannot fit in the side of this. I can't fit it on this page in Diophantus. Like, I don't have enough space to write down this beautiful proof. And he said that, he wrote that down in the 1700s. It didn't, we didn't solve this until 1994. Pretty sure the dude was making shit up. The dude was making shit up. He did not have a solution, or if he did, it was wrong. And I don't remember what it was, but in my graduate abstract algebra class that I took in college a while back, there's a common mistake that people make regarding some sort of mathematical abstract algebra object. There's a common mistake that people make, and the speculation is that Fermat made that mistake. So he thought that one thing was true, and it actually isn't true. That's the level of detail that I can explain this stuff to at the moment. Let's move on. Okay, so there's our little bit of flavor and story. Today we are going to be working in... let's use green. I think green and red look nice on the stream. So in Notability, I'm going to try to see if I can move this color. Can I? How delightful. Yes! Okay, I can just tap and drag the colors at the top to rearrange them. That's really, really nice, really delightful. Notability is an incredible app, everybody. You should get it. So we are day 7. We're going to be working linear algebra. Over the last 3 streams, we've been doing linear algebra, which is honestly my favorite subject in math. It is the perfect subject in math because it is extremely useful. It is extremely useful. In fact, there was a comment yesterday from somebody in the chat who said, "This is really cool. I'm a new viewer. I'm an economist, and we use linear algebra every single day to solve something." And he was like, "It's so cool to see how it's useful in other fields." And I was like, that's great that you think that I know that, but I don't know that. I know how it's useful in mathematics. It is so useful in mathematics because math can be an application in itself. You can use linear algebra in more abstract, more pure math subjects. But I don't know. I mean, I only know surface level, but I know it is tremendously useful in artificial intelligence. And that's why it's all the rage right now. ChatGPT is... ChatGPT, there's a saying that it is giant inscrutable matrices. Like humongous matrices. Over the last couple of videos, we've defined that a matrix is a humongous grid, or it's any grid of numbers. They can have a different number of rows and a different number of columns. but the most interesting ones are square, so N and M are the same. And there's a saying that ChatGPT is giant inscrutable matrices, that's all it is, and we don't understand how AI is thinking because it's inscrutable. It's so big, these grids of numbers, which are kind of like I think that's the weights of the matrices, and ChatGPT has, we've downloaded the internet, we've downloaded the entire internet, and then whenever you ask ChatGPT about, I don't know, ducks or acorns, whenever you ask, or cats, I don't know, like whenever you ask it about anything, it will say, oh, I've already seen a bunch of Reddit articles about that, and here's generally the pattern. Here's the best fit line. This is roughly what that looks like. And then you ask it a new question, and it's outside of the data set. There's that little red dot, and it gives you an answer that's pretty close to correct. Not completely correct, but pretty dang close. So there's my rough, hand-wavy, inaccurate, but somewhat accurate explanation of how AI is useful for how linear algebra is useful for AI. Hey, how's it going, G-Guy? I'm fully convinced that the smoke detector is in your apartment. I have daredevil ears. I'm fully convinced that you're right, too. And I've been very lazy. I apologize. But I've gone over there, and I've stood next to the one that I think is the right one, but then it sounds like it's in another spot. Like, it doesn't sound like the one that I think it is. It sounds far away, and then I go out in the hall where I think it is, and I don't hear it at all from there. It's like, it's this quantum fire detector that is driving me crazy. So, trust me that I've thought the same thing. Yeah, replace every 9-volt in existence. I agree. In the meantime, I'm going to close this door. Also, good to see you, G-Guy. How are you, man? Good to see you. G-Guy, I think you're in the proper superior horizontal stream. I'm also vertically streaming to YouTube Shorts at the exact same time, which is crazy, I think. That's a pretty cool streamer trick that I've learned over time. But yeah, good to see you, dude. G-Guy is a regular from my guitar channel. And I think that you joined the recital last night. I think it went really well. I'm somewhat happy with how it went. I think that there were some issues and there's some drama going on. I don't know if you're in my Discord, but there's some drama going on in the Discord right now. But that's not what we're doing at the moment. We are going to be working problems from... So let's do a little bit of review. Yesterday, I introduced Strang. And for the last couple of lectures, these are practice sessions. The last couple of streams before, we were working out of Shilov. This one is linear algebra for mathematicians, roughly. Like, it's really mathematician for, at the very least, we can say it's a second course in linear algebra. Strang is a first course. So, first course is what I was looking for, and now I found the textbook today that I want to be working through. Today, I'm going to try to solve problems I have not looked at yet from both Strang and Shilov. And we're going to be comparing the treatment, like the written description of some concepts from both textbooks. I haven't looked yet, but I expect that today we will be getting the definition of what a linear space is, or really what is the definition of a vector. That's what I'm guessing both of these books are going to do. I know Shilov does because I read that part. And spoilers is that a vector is any number, anything that you can multiply by a number. For example, 2 times 1, 2. You can multiply, so this is a different thing. It's like this 2-dimensional grid with 2 numbers, and then this is a single number. We write single numbers like that, and we write double numbers like that. You can multiply across these worlds. These are different worlds. And 2 times 1, 2 is 2, 4, right? And you can also add these things. For example, 1, 2, and 3, 4, you can add 2 vectors. 1 plus 3 is 4, 2 plus 4 is 6, right? So, what else? This is called the first one is called multiplication by a scalar. A scalar is this number, and then the second one is closure under addition. Closure of addition, whatever. That's a fancy way to say that you can add, that you have addition. Any time that you have 2 vectors, you will get another vector. I don't know if I want to just jump to copying the books or if I want to try to give my own explanations of these things, but I can try to... Oh, you were vertical. Okay, I got this backwards then. What? All right, well, you're vertical. Well, you know what? Come join us in the horizontal stream. Horizontal is superior. But you do you. Whatever you prefer. That's annoying to me that YouTube is clearly, like, you probably got the push notification for the vertical instead of the push notification for horizontal. Yeah. I don't know. I've got hot takes about that, but I'm not going to get into it. These are the rules. These are 2 of the rules for to create a vector space, to create vectors. Pretty sure that I'm missing some. I know that you need to have subtraction as well. Let's see. So you need to be able to have subtraction. You need to have a 0. And you need to have a 1. Okay, I'm being hand wavy here for the purposes of explaining to a wide audience, but also because I think it's useful for everybody. Okay, what do I mean by 0 and what do I mean by 1? I think that these are focusing... We need to have both, I think. Let's give this 4-1 and 5-1 and 4-2 and 5-2. I think we need a 0 and 1. I think so in both the scalars, in the number that you can multiply by, and I think that you need to have both of those for the vectors. Okay, just a reminder here. Just scalars are the numbers a, and then vectors are the other things like v. We're usually going to use a, b, c, d, etc. I'm going to write, for example, in R. Those are any number like 1, 2, 1/2, pi, lots of other numbers. And then here, vectors, we're usually going to use VW, UVW, etc. In the vector space, for example, in R2. So, one more time, an example that combines these two ideas is 2 times 3, 4 equals 6, 8. Okay, still with me? Any questions, anybody? Also, I know that there was a comment I wanted to get back to. G guy, I am vertical. You were right. I am wrong. Sorry, the chat is different. I don't know what you mean by that. I have been enjoying these even though over my head. Good. That's the goal. That's the goal. I want everybody to get something out of this, even if you do not know math. Even if this is the first time you've seen any of this before, I hope that this can be interesting and entertaining. And maybe you get 1% of what I say. Maybe you get 10%. Maybe someday you'll get 100% of what I'm talking about here. But hopefully it's enjoyable anyways, and I'm happy to hear that. Okay, so these are some of the rules that we need that create what a vector. All these rules. Where's the word rules? These rules create vectors. And one more time, geometrically, we can think of vectors as an arrow that starts from the origin, and it has some length, L, and it has some direction, maybe theta. Okay, so like remember in trigonometry and other classes, you would do things like create these right triangles, and you'd use, hey, the Pythagorean theorem popping up again. You'd use the Pythagorean theorem like x squared plus, in this case, x squared plus y squared equals the length squared, the hypotenuse squared. So a vector is anything that has a direction, like an angle, and a length. And then with that, so let's call this lovely arrow V, and I draw a little arrow above it, again, because this is an arrow with a direction and a length. With that, we can multiply V by a number. Maybe I multiply it by -1, negative V. So here, the number that we multiplied with I was using A. In this case, A is -1, right? So it's the same dang vector, but it's in the opposite direction. Like we multiplied it by -1, but it has the same angle. It's just in the opposite direction. let's see. So that's one example. Another example is that, well, let's say that this is along the y equals x line. So maybe this is the point 1, 1. And then maybe the point... Oh, well, I would have had a better example, but this is decent, I think. 1, negative 1. Maybe this is another vector. Okay, so we're usually using following Strang. We're going to use 1, 1 is v, and 1, negative 1 is w. Then what happens if we add those two vectors together? Then we get a third vector. TUVW. Or we could go to x, but usually you go the other way. U equals v plus w. And if we add the coordinates of those, the first coordinate is 2, and then the second coordinate is 0. So maybe this is like roughly twice as far this direction, but it is, but now the y direction, like the y-axis, is now 0. Hey, Viking Doomslayer, good to see you, man. Ooh, math. Yeah, no, I don't get this, but I will learn. Hell yeah, that's the point. I hope you pick up a little bit of it, and no worries if not. I hope that you enjoy it nonetheless. If nothing else, we can appreciate the beautiful kitty cat, Luna, at least in the vertical stream. Viking, are you in the vertical stream or the horizontal stream? G-Guy is in the vertical. I hope G-Guy switches over to horizontal. It's just, everything is better in the horizontal. Cool. Any questions? Let's move on. So, yesterday, we solved some problems from Strang. I was working in section 1.1, and then here's my notation, everybody. 1.1 point whatever is going to be the exercises from that chapter and section. Yesterday, we worked problems 1 through 7, and we worked the problem 10. Okay? You with me? Today, I definitely want to do 118. I can do an 8-9 or a comma. We're going to do problems 8, 9, and 11 to something. From Shilov, in the past, we did chapter 1. There's no sections in Shilov. There's just problems from a chapter. We have so far done problems 1 and 3. And today, I want to work... Oh, wait. Yeah. Oops. Chapter 1, problem 2... and maybe more? I don't know if we're... Yeah, I want to try to take a look at 4. This is super confusing, y'all. I hope that's okay. I don't know if this is the right notation. But basically, if you look at this, I'm making all this up on the fly, so I don't know. Last dot separates section, chapter and section versus exercises. It could be something like chapter 1, we did chapter 1, 1 and 3, chapter 1, 2 and 4, and in Strang 1, section 1, 1 through 7 and 10, and 1, 8, 9, 11 through whatever. That's starting to feel a little cleaner to me, but y'all let me know what you think. Yay, cat, vertical. How do you go to the horizontal stream? Go to my channel, so click on my name, and then I hope that you'll find it there. I don't know. I guess click on my name, then if you need to, click on the live tab, and I think that you'll find it. It's a little harder than you would hope, but you know, it would be great if YouTube made this easy, because I think that this is a very cool technique. It's kind of a power user, streamer power user technique, I think. Anyways, let's get going. Just a little inside baseball to those who might be interested. The reason that I'm streaming vertically in addition to the regular horizontal is that vertical live streams, anytime that the stream is vertical aspect ratio, it goes to YouTube Shorts. And then you get better discoverability. I have seen this very much time and time again with my guitar stream. When I stream horizontally, 3 viewers. When I stream vertically, thousands of viewers. So it's crazy. It's crazy how different the two are. Even though this content is not very good in the long run vertically. So I don't know. I wish that there was a button. This is another really good piece of feedback to YouTube. I know some people there, so I want to try to write down all my feedback. It'd be great if there was a button on the screen also horizontal, or also full screen or something, or whatever. Like if you could just tap a button and then jump to the other stream, that would be so cool. All right. So there's our goal, there's our agenda. Today I want to be solving problems, as well as taking a break to hang out, chat, and what am I looking for? What's the term that I'm looking for? Hang out, chat, and give my own hobbyist, layman, rusty explanations of concepts. Okay, and now, yeah, okay. I do want to take the opportunity to give my own explanations of things, because I think that's fun. It's maybe a little bit more fun for people who haven't seen this before, like Viking in the chat right now. Because if I just jump to the problems, I feel I might lose, non-math people. Definition of vectors. Something that we... something that I've been careful about just now to say is, for example... I've been saying, for example, as I talk about these, examples, I've been giving the examples of numbers and these types of vectors. What's really cool, and the reason that linear algebra is so dang useful, is that this clearly is not the only example. Otherwise, I wouldn't say, for example. I would say it is a real number times a pair of real numbers. Like, you can think of these as pairs. Like, it is literally the exact same thing as this pair. It is the exact same thing. This is just a different notation. But rules also apply elsewhere. This is why linear algebra is so dang useful. We need to have a thing that when you add two of them, you get another one. And when you multiply it by something else, you get another thing. I hope that makes some amount of sense. I have a good example here that a lot of people are going to recognize. X squared plus 1. This is a polynomial. This is a polynomial. And guess what? You can multiply a polynomial by a number. Two times x squared plus 2, right? This is also another polynomial. Maybe p and q. Like q, yeah, p and q, or p1 and p2, or whatever. But we started with a polynomial, we multiplied it by 2, and then we got another polynomial. We can draw that even. Like, we've seen this in regular algebra. I don't know. It's going to look something like that. Like, the number 0, 1 went up to 0, 2. Like, all of these numbers got doubled. So that's pretty freaking cool, if you ask me. You can also multiply it by a negative number, and then you get a negative polynomial, maybe by negative x. You can add two polynomials. Lines are just one example of a polynomial, like y equals x. And then we can get all the same examples that we had before. Like, if we add y equals x, I don't know, what if we add y equals negative x? Then, if you add those two together, you get y equals 0, and that is also another polynomial. Right? So that's cool. Okay, so let's see. How do you make a vertical stream? You need to create a separate stream key. I mean, the easiest way to do a vertical stream is use your phone and hit the live button in the main YouTube app and go live. But if you want to be doing horizontal and vertical, you create a second stream key. You name it something like vertical. I have two. I have one named vertical, one named horizontal, and then you download the Atom plugin for OBS, and then that thing helps you makes it easier to have two going at once. As long as your video output is taller than it is wide, then it will stream to YouTube Shorts. But yeah, it's too complicated. It's like very power user. I probably wouldn't know that if I didn't work at YouTube in the past and do a guitar stream for a long time. No offense, man, but how do you guys even like math? It's super confusing. Good question. Very good question. I don't know. I love it. I just love it. I just do. It's puzzles. It's board games. Like, I'm a geek. I mean, that's a short answer, right? Like, I'm a fucking geek, y'all. It's board games. Board games are math. Like, do you like games? Do you like video games? Video games are math. Like, when you solve a puzzle in a Zelda game or something, like, that's math. Like, you're just, like, figuring out the answer to some sort of puzzle. To me, math is just puzzles. And there's a lot of crossover. There's a lot of other reasons to like math, but that's where it comes from for me, I think. I played video games when I was young, and then I got into puzzles, and I got into math, and etc. Everyone is different. It's in everything. Hey, why not just upload the edited version of this live as a video? It'd be way better. I will also do that, maybe. But right now we're streaming so that I can chat with you while we're live. Nice to meet you, Tanish. How are you? G-Guy, people can ask questions and bring up concepts to expand on during a live share. 1000%. That is exactly the reason. Okay, so we got people in the horizontal chat now. That's nice. Let's go ahead and... Why is there a learn more? Okay, I can't believe I'm screwing all this stuff up so much. You all are in the horizontal... No, you're in the vertical, aren't you? I hate how the vertical is always more... It's more popular than the horizontal. Oh, well. Yeah, I mean, Tanish, feel free to just tune out and come back and wait for the edited version. It may never happen because I'm lazy. It's a lot easier. It's infinitely easier for me to just go live and hang out. And I think it's a better product because people can chat, there's interaction, there's community. But then it's 10 times as much work for me to edit a video than it is to just go live again. So I've run into this in other streams in the past, like, I could spend 10 hours editing a video, or I could just go live 10 more times instead. I'd rather just go live 10 more times. So let's get back to it. I'm getting the understanding here that we should just continue. We should do some problems. Tanish is getting impatient. Too much yapping, and that is valid. That is valid feedback. Let's keep going. So I was just defining what vectors are, and I gave a cool example of something that a lot of people are familiar with, which is polynomials. So I can try to state a little bit more carefully what those rules are, and I'm going to give my very brief definition, and then we will take a look at what Strang and Shilov define this as. In short, A needs to be an element from a field, something called a field, and V needs to be a vector from a vector space. What the hell is that? What does that mean? A field are numbers with addition, subtraction, multiplication, and division. You might ask, isn't that all numbers? And you would have a very good question if you ask that. And then vector space is exactly what we're trying to define right now. Trying to define. So the most important thing at the moment is what a field is. And what do I mean by numbers with addition, subtraction, multiplication, and division? Well, can we come up with a good example? In math, the first thing that everybody learns are what we call the counting numbers. 1, 2, 3, dot, dot, dot. Right? Then we learn the integers. I like to do this as 0, 1, minus 1, 2, minus 2. So this is all of the integers, positive and negative. You with me? Like, that is all. Here, this is probably clear. Let's do it this way. 0 plus and minus 1 plus and minus 2 plus and minus 3, dot, dot, dot. Then we teach the little children how to create fractions. For example, 2/3 is a fraction, right? This is a number where A, we could say that A needs to be any integer, but B needs to be a whole counting number. It can't be 0. Notice that 0 is not in the counting numbers, right? So we treat something like 1/2, or like negative 1/2, like A equals -1, which is in the integers. Like the numerator can be negative, but the denominator needs to be positive. Indeed, B is greater than 0. Here's how I like to define this, but you can define it slightly differently. Notice that here, something that's important is that 1 divided by -2, we need to rewrite as -1/2. I'm trying to utilize that. And somebody who's better at math than me could probably give a more precise example or precise definition, or tell me why I'm wrong. I haven't seen this before, like this exact way of saying it. I usually see A is in Z and B is also in integers but B is not 0. Like, maybe this is just easier to say. Like, you can't divide by 0. But yeah, to me this is just like a little cleaner. I don't know. It's neat. All right, I'm rambling. But the simplest numbers that we all learn are the counting numbers. They exist in the natural world. Like, I can have 2 notebooks. I have 2 notebooks right here, right? But I can't see in the natural world a negative notebook. Like, I can't see physically a negative notebook anywhere. I can take away a notebook and I can call that a negative notebook. Like, if I add a negative notebook to this, then I have 1 notebook, right? But that's our invention. Like, a negative number isn't natural. It's an invention that we've created. You could say like a debt. Like, I added, I bought a TV today and I put it on my credit card. Therefore, I added -$100 to my credit card, or to my net worth. Like, I added -100. I have a debt. Like, I owe $100. That's an invention that we've made. in a sense. It's not natural per se. But so we have counting numbers, we have integers. The next most complex thing are the fractions. After that, we learn these fancy numbers, the real numbers, including things like pi and the square root of 2, and other numbers that do not have any pattern. They never repeat. They never repeat in the decimal expansion. They go on forever, quote unquote. Those are the real numbers. And then, I don't know if they teach it in high school, I don't remember, but the complex imaginary numbers, I think that you learned this briefly in high school. You imagine that you can solve this equation for 0. Like, what if there was a number that you can square and it equals -1? A plus bi, where I equals the square root of 2. Oh, what am I talking about? Square root of 2. Square root of -1. Yeah, those are the most common mathematical objects or mathematical worlds. Some math, I like that term, some math worlds. But now we are creating some new math worlds. Like, I want to say that linear algebra is creating some new math worlds, like the pair of numbers, a triple of numbers. These are the examples that we've used so far, but then I don't know if this is accurate or not to use it like a P, a blackboard P. Polynomials of degree n. So anytime that you add two polynomials of degree n, let's say, what am I doing? an xn plus a1x plus a0, a naught. If we add that thing with another one, then we can create a new. We can add each term individually, x to the n plus dot 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 plus a1 plus b1 x plus a0 plus b0, right? And we could just rewrite that one more time. Cn x to the n plus dot 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 plus c1x plus c naught. So, therefore, when you add two polynomials, you get another polynomial of the same degree, up to the same degree. Yeah. Any questions? So that's like a new motivating example. Here we have been talking about R, but if we come back up here to me this is like complexity. complexity as we go to the right, well, Q and Z, right? Like those are less complex, and the integers are even less complex. So can we use the counting numbers, the integers, or the fractions for a vector space, for this fancy thing called a vector space? Well, this is going to be sloppy notation, but we can certainly add and we can certainly subtract. Oh, wait, sorry. We can certainly add two whole numbers. If you have two whole numbers, like 1 plus 2, that is another whole number. That is another natural counting number. So that works. But we cannot subtract numbers and still be a counting number, right? So that means we do not have subtraction of the in the counting numbers. That is why we need to create the integers instead. This one has the negative numbers as well. You can add two integers and get another integer. You can subtract two integers and you can get another integer. Okay? So that's great. But what the hell are we doing again? Like, let's come back to the goal. We are trying to understand what a field is. And in some sense, if we understand what a field is, then we can get a better definition of what a vector space is. Yeah, that's not the greatest explanation, but whatever. So let's say reminder. Also, what's your name again? Tanish? I am looking for somebody who wants to help edit these videos, so I will literally pay you if you want to help me edit, because it's too much work. But I would, I think it would make for a fantastic product if somebody wanted to help edit. I don't like editing. We are defining a field F. And I said that it needs to have addition, subtraction, multiplication, and division. All of this math stream is hand wavy. That's mathematician speak to say, like, this is not completely accurate, but it's really dang close. Like, I'm hand waving a little bit here. So I'm omitting some precise details, and you won't see this kind of explanation in a book, but I think that a lot of lectures in math classes, if you go to college and study math, a lot of lectures are hand wavy, because this to me is the best way to explain a concept. You kind of hand wave and explain it with analogies more rather than like the very dry, precise, 100% accurate explanation. I said that we're going to solve problems. We will solve problems. We will probably not get as far as I wanted to, but we will be solving some problems in a second. But this moment is great for me to practice my understanding and ability to explain linear algebra. And this is going to motivate some of the problems that we're doing. So instead of reading the sections about this stuff, I am giving my own version of the theory from these books. So we're defining these. So we saw that Z works for both of those, but the counting numbers did not work. And we're testing each of these. Z, we're going to test next. What's the simplest math world that we can call a field? If anybody in chat knows, feel free to give us a spoiler. ZQRC, this is the complex world. I hope that we get one before we have to start imagining stuff even more. So we saw that N did not work. Now what about Z? We saw that Z has addition. Z has addition and it has subtraction. It has multiplication. We can multiply two integers and get another integer, but it does not have division. Okay? If you need an example for that, 1 divided by 2. The number 1 is a counting number, the number 2 is a counting number, but this fraction, 1/2, is not a counting number. 1/2 is not a counting number. 1/2 is a fraction. So Z doesn't work. What about Q? Well, Q, all the fractions, you can add two fractions, you can subtract two fractions, you can multiply two fractions. Can you divide two fractions? Yes. Almost. Anytime you have two fractions, A divided by B divided by C divided by D. What is that? In school, we learned that dividing by a fraction is like multiplying by the opposite. Like you move top to bottom and bottom to top. You flip the fraction and then you multiply. AD divided by BC. That looks like it's a fraction, right? AD divided by BC. No. Unfortunately, no. And I wonder if anybody... We don't have many people in chat. Today's more quiet. I wonder why. I thought that today would be more busy, given that we're also streaming vertically, but, oh well, whatever. Why not? Why is this not a fraction? the reason it's not a fraction is that b we assumed is not 0, and that's fine. And we have d is not 0, but c can be 0, right? And here, c can be 0. So this is not in Q. So a field. Now, this is just like one tiny counter example. One tiny counter example. And if we made that a problem for Q, it would also be a problem for R. It would also be a problem for the complex numbers. So we make an exception. Like, we say that when I said that we can do division, we're going to say that division other than 0. Like, as long as we can divide by anything besides 0, then we still have a field. This is going to be our simplest example of a field. And now, are the rational numbers. The simplest field are the rational numbers. And now, if we come back to the idea of a vector space, we want the ability to multiply a vector by a number. And I've been using this example, 1/2 or 2 times something. Maybe 1/2 times 2, 4 is 1, 2. So now we are we can treat this vector space as not being numbers like pi or square root of 2 or the other real numbers. They have to be integers, counting numbers, integers, or fractions. All of those are fractions, but you know what I mean. Okay, that's cool. But what about this example? AV equals 1/2 times 2 pi, 4 pi. Oh, wait a minute. Okay. That's interesting. We will still be able to multiply. We can move in these the number that we are multiplying by into the equation, and we get pi and 2 pi. Okay. So a vector is a pair or a sequence of numbers. And I might be mixing together two different math concepts, but in this case, like, as long as we can multiply each coordinate by the same number, remember that this is a scalar. A is a scalar. As long as we can multiply every element, every coordinate by the same number, then we get another. We have multiplication by a scalar, which is another vector. Like AV1 maybe is now, we can call this a new vector V2. But this is interesting because here, this number came from Q, but then this vector came from pairs of real numbers. Okay. That seems to work. That's interesting. Yeah. I'm going to leave it at that for right now in terms of defining a vector space in my own way. I think, spoilers, I think that I just created a module which is slightly different, where this object can be different from this object. And it's like a slightly more abstract idea than we're going to get in Strang, but I bet that we will get. I think that modules are an appendix in Strang, and they might be part of the chapters in Shilov. So, hey, Stand Strong, good to see you, dude. How are you? What's up? What's going on? I see we have chat going on in. All right, everybody's in the vertical, I think. Or wait. Are you all in the vertical chat, or... No, you all are in the horizontal? No, you all are in the vertical, aren't you? I'm super confused. I don't know. It's super confusing. Streaming is hard. I could be wrong on this. Maybe we are still doing a vector space, but a more abstract idea is a module. And then you can define, like, a vector space as a simplification of a module. Like, I think, like, you talk about a module over a field, and if the module is the same object as a field, then it's a vector space. I don't know. Something like that. Let's shut up. Let's get to Strang exercises. I'm starting to lose my confidence. Let's, I think I know some math. I think I remember math more or less. I don't think I'm completely making everything up. Where are, my copy of Strang is still in the mail. Where did I put it? Dang it. I really should have gotten this set up earlier. Preview. Open recent. My friend sent some photos of the first section's problem set. Open recent. All right, so as I said, we're going to try to work 1, 1, 8, and 9, and then we're going to try to work 11, maybe 12. I think that we might be able to get that far. Strang 1, 1, 8. All right, how's it going, folks? I should turn on music soon, but oh well. Every combination of v equals 1, negative 2, 1, and w equals 0, 1, negative 1 has components that add to blank. Find C and D so that CV plus D, I might have to take a break. Yeah, here's a good, let me finish writing this down, and then I'm going to get some coffee, take a short break, and be right back. So I'll let you all think about the solution to this while I take a short break. Good timing in a sense. All right, so be right back, y'all. Here is the question. BRB. Y'all, that took a lot longer than I expected. Oops. The iPad even disappeared. I apologize. Yeah, that took a lot longer than I expected. I got a second call that I had to take as well, so I apologize. I'm back. Hello, my name is John. I am the math hobbyist. So, I'm the math hobbyist, and we are working on Strang. I think his first name is Gilbert. Gilbert Strang's linear algebra section 1 exercises. So, iPad horizontal, how do I get it running again correctly? Why isn't it working? Okay. Wait, what? Technology is hard, everybody. But, by the way, this is what I use. I use Air Server. It is an incredible app. You all should buy it. I love it very much. Why isn't it working? What's going on? Oh, dang it. There we go. Okay. What's going on, chat? What's up? Nope, nobody in the correct horizontal chat. That's fine. Yeah, what's up? How's it going? Stand Strong, are you still there? How's it going? Damn. Yeah, it's 11:34. That break took longer than I wanted. It's because I got a really great second call that I'm very grateful for. Cool. So, what's up? What's up, y'all? This is a weird concept. I am open to feedback. I am receptive. I love feedback. I would love to know what you all think of this entire math stream concept idea. This is a practice stream. This is literally me practicing. Do not expect a polished lecture. Be right back. All right, now we're back. All right, so what the hell? What is this problem again? What are we doing? We are trying to understand this vector v and this vector w, and it's asking what do they add to. V plus w is 1, minus 1, 0. Find c and d so that cv plus dw equals 3, 3, negative 6. Okay, so cv plus dw is going to equal cv plus dw is c. For the first component, cv plus dw, let's do this carefully, just so that everybody follows along here. This is c times 1 plus d times 0 for the first component. C times negative 2 plus d times 1 for the second component. And then c minus d for the third component. Y'all still with me? C minus d for the third component. C plus d minus 2c plus d, c minus d. And now we want to solve. The problem is asking solve for 3, 3 minus 6. So we need c plus d equals 3. C minus d equals negative 6. I see it from those two, I think. Or not. I thought I did for a second. But we have 3 equations and 2 unknowns. So I know that we only need 2 equations to solve. Let's just do it step by step. We can replace maybe d equals 3 minus c And then here we have c minus 3 minus c to replace d equals -6. So then we have 2c minus 3 equals -6. I'm going to try to do that in one step in my head. I see c minus -c, then I write down 2c, and then I have minus 3 equals -6. I'm going to add 3 to both sides at this point and say -3. That's like a tip on how to do some mental math in those polynomial, like solving algebra problems. Cool, we got the first one of the two. Now we bring it back. Bring it back, bring it. Isn't that a song? -3/2 minus d equals -6. On these, instead of multiplying by a -1, like add 3/2 to both sides and then multiply by -1, I like to think of this as d, move d to the other side, and then add 6. Somehow in my mind, that's easier for me to do this in one step. So we've got 6 minus 3/2, which maybe I could do in my head, but so 12/2 minus 3/2 is going to be 9/2. Did I do that right? 12/2 minus 3/2, 9/2. Yeah, is d. So our solution is CD equals -3/2, positive 9/2. Easy, easy. We got this. We got this. Okay, now why? Next question was this part. Why is 3, 3, 6 impossible? So we know that whenever we have a system of equations, they can have no solutions, or they can have one solution, or they can have infinitely many solutions. So what we're going to see is trying to solve this system of equations right here for 3, 3, 6. We're going to see that that's impossible. So maybe we should be able to just use 2, but maybe not. Let's see. Let's try to use the same ones that we used, because in my head, somehow these are easier than using -2c plus d. I don't know, whatever. Let's see what happens. We want the first coordinate, c plus d, to equal 3, and we want the third coordinate, c minus d, to equal 6. Let's do the same process and see if we can find a solution here. The same process that we did above. So if c and d equals 3, first off, is there a way... Oh, you know what? Look at this. I think that if two equations solve to 3, 3, and there are 3 variables, there's no way that this third, that the third coordinate can be different. So if we wanted to take a shortcut, we could say that it's a system of 2 equations, of 3 equations with 2 variables, and first and second coordinates equal the prior solution. There's like a really fancy answer. I think that's a fancy answer to a fancy ass answer to that question, but let's see if we can get it this way. C plus D equals 3. We get D equals 3 minus C. And then C minus D equals 6. C minus 3 minus C. So I'm replacing, wait, what? Yeah. C minus, we solve for D in terms of C. And then we replace D in the second equation. First equation, second equation. We replace D, and here's the rest of that equation. 2C equals 3. C equals 3 halves. Just reminding ourselves, is that what we got before? No, before, for that other type of solution, we got negative 3 halves. This time around, we got positive. Okay. And now, oh yeah, I think that what we should have done next is make sure that the second, yeah, we should have checked ourselves here. Negative 2C plus D equals, but we had the hint that this is a solution, so I'm pretty sure, like, if we run through the algebra, we're going to find that it should equal the second coordinate there. Yeah, we had the hint that it is a solution. Now here we're going to see that it's impossible because the third coordinate is not going to match. I misspoke. The second equation is the third coordinate. That's confusing. And now, yeah, the second coordinate is minus 2C plus D, and we wanted to see if we can get 3, 3, positive 6. So the second equation is going to be that thing. Let's do a little bit of magic. Bring that up there. And bring that there. So what I did was I used 1, and 3 to get a potential solution. Potential solution. If there were a solution, these would be the scalars C and D that we use. All right, let's take a very brief chat. Hey, Alok, hello. How you doing, bro? Bro, I'm doing very good. I'm doing very, very good. I just got a very nice, very good call that I'm super happy about, and I'm always having a good day whenever we get to stream. And thankfully, you're in the right stream too. There are 2 streams. One is vertical to YouTube Shorts, and one is horizontal. The horizontal is better, so I'm glad that you're in the horizontal chat. just put you on screen, bro. How are you? I see that was 4 minutes ago. I wonder if you're still here. How's it going? Do you study math? Are you a math fan or a mathematician, perhaps? So what we're going to see, because Strang gave us a hint, is that equation 2 is not going to work. We're plugging in C and D into this equation. We found, oh, whoops. I didn't complete here. D equals, why is that? Why is that in a different color? D equals 3 minus 3 halves, which is 6 halves minus 3, which is 3 halves. Now we are going to see that 3 halves is not a solution. -2 times 3 halves plus 3 halves equals. We should see that it does not equal 3. So I'm going to write it like this. Here we have -3 plus 3 halves does not equal 3. Just, yeah, I'm confident on that. Left-hand side is going to be negative. -6 halves plus 3 halves is -3 halves. And -3 halves is not 3. So, to answer the question, why dot dot dot. To answer that question in a sentence, we're going to say, not solvable. Like the 3, whatever. The system of 3 equations is not solvable. Whatever. Good enough. Oh, cool. You're a high school student. Nice. I love getting high school students because y'all haven't seen a lot of this math before, I think. And I'm trying to practice, like, can I explain it to people who haven't seen it before? So please, feedback, super duper welcome. Let me know what you think of this stream idea. Starting my hands with the derivatives and integration. Cool. Alok says, derivatives and integration. Cool. That is calculus, which is next. I don't know how often I want to stay on each topic. This is a brand new channel, a brand new stream. I don't know how long I want to stay on each topic. So far, this is I did 3 streams on number theory, which is pure math. It's the queen of mathematics, studying prime numbers and other useless stuff. And now this is the 4th stream on linear algebra, which is the best math because it is incredibly useful. It is very applied, and it is very theoretical. To me, it's my favorite. I love linear algebra. And I'm thinking that next I want to do calculus, which also is can be a pure math subject in and of itself, but I think it's mostly useful. I think calculus is mostly applied math. Even analysis, like you study analysis so that you can calculate physics problems and engineering problems and things. You can see how far you can throw a baseball. I don't know, like, yeah, that's just my bias. My bias is towards algebra for pure math, but that's me. There's a big divide. There are people who love analysis, and then there are people who love algebra. I'm an algebra person, but I want to practice and get really, really good at calculus, anyways. I'm more into physics, but as we know, maths is the language of physics. Exactly like what I just said. Calculus kind of was invented for physics by Newton. Newton and Leibniz both independently created calculus. Leibniz kind of invented calculus as a pure math. He was also interested in logic and philosophy, which are both very pure subjects. And then Newton was the engineer who invented it to throw baseballs and stuff. Yeah, I learned some about linear algebra from your previous live video. Hell yeah. I'm glad that you watched it. And yeah, I do take side with you. I also love algebra. Nice. I'm gonna convert you over to the dark side of pure mathematics. Although someday, this is in the far future, you are a physics major, or you're interested in physics. You're in high school. You're not a major of anything yet, but you're a high school student. One of these days, if you continue with physics, someday, let's switch over the scene. Someday we will study these scary ass books. I did this book in upper division, second course of quantum mechanics when I was in college. I almost finished a physics minor, but I didn't. I really loved this class. It was great, but it was just super abstract, and I don't think I totally understood it at all. And I almost took a second course in electricity and magnetism. This book is scary as hell. This book is scary as hell, Jackson. So someday you could teach me this electricity, like big boy electricity, and we'll work together on big boy quantum mechanics. It's good to get more physics people in the chat. So, yeah, man. Hope to see you more often. Oh, I just know the names and like the core intuition, but not the pure derivation and the pure science behind it. Oh yeah, me too. I'm learning everything as I go. I don't really know very much. I haven't done math or science in a very long time. I graduated college like 15 years ago, and I've been working in software for the last 10 years. I guess I graduated like 12 years. So I don't know. What year is it? But yeah, I haven't done math or science in a very long time. I've just worked in software for a while, and now I'm trying to rekindle and bring back my love of studying and learn math as a hobby. So I'm going to take a very short break. This time it's only going to be 2 minutes. Be right back. Dude, thank you. Thank you. Heart hands. Thank you. I see your last comment. Man, I just love your vibe for some reason, to be honest. That means a lot. That genuinely, truly means a lot. Thank you. All right, let's keep going. Let's keep going. What's going on? What's going on, chat? What's going on, fellow nerds? Okay, my computer's like running out of space or something. There's a memory leak in OBS, so that's annoying. I hope that the stream doesn't crash in the middle of the stream. It might. We'll see what happens. All right, so I said derivatives and integration calculus next week, next stream, next day, next stream. You tell me. What's your name again? Alok. You tell me, Alok. Like, do you think that I should stay on one topic for a full week, like do 7 streams in a row on one topic, and then do the next week on the next topic? Or do you think I should do like every 3 days or every day? Like, how often do you think I should rotate? Should I mix all the subjects together, like the same class, the same stream on number theory, linear algebra, and calculus? Or, like, I don't know. Like, all this is brand new to me, and I'm trying to figure it out as we go. So let me know what you think. That chat is tiny in this stream, so it's so annoying. Like, chat is so hard to show well from YouTube. YouTube is inferior to Twitch in so many ways, and this is one of them. It's so much harder to embed chat in YouTube, but YouTube is where I want to be. I said that I wanted to solve. I said that my goal was to solve all of these problems, and we've done 8. And I wanted to try to do 1, 2, and 4. So I don't think that we're not going to get to Shilov 4. I want to skip 9. I don't think I solved 8 on my own. I thought that was new to me. I don't remember solving 8 privately. Let's try to do Strang 11 and Shilov 2. I want to make sure I at least get one problem from Shilov in this stream, because the thumbnail has Shilov. So Shilov 1, 2. I believe that I pre-solved this one. I don't know where my book is. Here it is. Shilov. Beautiful book. Not the book I wanted, but a beautiful book nonetheless. Not the book I intended to buy, but now I'm glad I got it. That it accidentally fell into my life, I suppose. This book is hard. Is this the right one? Yes. What is 1.2? And I'm going to cheat and remind myself how I solved it. What is... That was 1.3. Okay, write down all the terms appearing in the determinant of order 4, which have a minus sign and contain the factor a23. Whew. Okay, so Shilov, problem 1 and problem 2 are both immediately on the determinant. The determinant is chapter 5 of Strang. So that tells you a little bit about how different these books are, and like how much the like this one is like much more advanced. So yeah, I'm not going to put it on screen, but I will at least write it out carefully, like verbatim. It's Get it verbatim. iPad. Chat, question, or comment or something. Let's see, what was it? I wish I could read it on the screen. Well, you can do like this, use some parts of everything and just show like their real life uses as along you teach them. But yeah, it would be more reliable if you were to stay on a topic for some time. I think so. And I think that the most natural, easiest to understand structure would be weeks. So we could finish and do the entire week on linear algebra, which I'm okay with. That just means that we'll do like the week of, like, I literally don't care. I literally just do not care. I just want to solve math. I just want to do math, and it doesn't matter to me what kind of math. I want to do some math. I'm fiending for some math right now. Linear algebra. Every stream, linear algebra for this week. Done. Thank you. You just greatly influenced the structure of the stream. That means that we're getting we did 3 number theory, and then we're going to get today's number 4, so 9 linear algebra, and then 7 calculus. I think that's okay. I think that's fine. I think that's nice. Okay. Like, that many in a row, that is. Number 2. Right? Shilov, number 2. Write down all the terms. One second. Alright, so I'm back. I hope y'all didn't hear all that. I don't think that you did. Let me know. Okay, so, and then sometimes like a combined class. Hooray, nice one. Okay, cool. Yeah, I think it's cool. And I do, yes, want to mix in applications and how this stuff is useful, and not just solve problems because that's not accessible to everybody. I want to have a little bit of talk of like how this is useful in physics or in computer science or economics. I don't know all of that myself, so I'm going to lean on you all to help me learn. Like, I know a little bit about computer science, and I know a tiny bit about physics, but I would love to hear about how this stuff is useful for other subjects. So leave a comment below if you're watching the stream after the fact. Good, you couldn't hear me. Good. Okay, so write down all the terms Cool. Shilov 1.2. Write down all the terms appearing in the determinant of order 4, which have a minus sign and contain the factor a23. Woof. Okay, so solution. This isn't a proof, this is a solution. We want all terms A we want to find all of these terms that have a negative sign in the determinant. Okay, so that is going to be from the last stream, all the terms where this sequence, I1, I2, 2, I4, every time that this sequence is odd, or the number of, n is the number of inversions of this sequence, to be more precise. Okay. Let's write down all of them. I like to keep everything in order. So I'm picking the smallest numbers that I can every time I can. And the 2 is always fixed in the third coordinate. 1, 3, 2, 4. Every time this sequence is going to have a 2. And I'm always going to keep increasing the last coordinate unless it's a 4, in which case I increase it to a 1. I don't know. Something like that. No, yeah, I don't like that algorithm. Let's do a different algorithm. I'm just going to write them all out and not explain how I'm getting it. So we can swap those two, and then those are our only options while fixing the 1. Here are all of them. And if I were to summarize how I thought of it, it's that I fixed the first coordinate each time, and then I swapped the 2 other options. 3 and 4, I swapped those 2, 1 and 4, 4 and 1, 3 and 1, 1 and 3. All right, now I'm just going to write down what n is and then what the sign is. So let's remember that n in this is the number of times that numbers are inverted in this sequence. So the number of times that a bigger number appears before a smaller number is another way to say it. the only time in the first one is a 3 that's before the 2. Right? So n is 1. And then let's just focus on that. A 4 is before a 2 and a 4 is before a 3. 4 is bigger than 2, 4 is bigger than 3, so there's 2. And this next one, 3 is bigger than 1, 3 is bigger than 2, and that's it. In the next one, 3 is bigger than 2, 3 is bigger than 1, 4 is bigger than 2, 4 is bigger than 1. So there's 4. On the next one, there are 3 inversions of 4, there's 2 inversions of 3, and there's 1 inversion of 2. 3 plus 2 plus 1 is 6. On this next one, there are 3 inversions of 4, and that's it. Cool. And recall that sigma is -1 to the n. So we have a minus sign, we have a positive sign, we have a positive, we have a positive, we have a positive, and we have a negative. That's cool. Somehow I expected... Something feels wrong. Am I missing some? Oh, yeah, I know why. Okay. The thing that feels wrong is that I expected there to be an equal number. I expected there to be an equal number of these. But just so that we see what happens, it's because we also have the terms with 2. I don't know. Yeah, there's actually a lot more. Because 1, 3, 2, 4 also... Yeah, there's a lot more terms in this. There's all the ones where 2 is the first coordinate. And then there are other ones like 1, 2, 3, 4. You know, where 2 is not in the third coordinate. So that's why the number of these sigmas don't match. Don't worry if you didn't follow that. The question was just asking which ones have a minus sign. So I think it's just this one and this one. So based on all this, the answer is A 1 1, A 3 2, A what the hell? 2 3. Is that correct? Yeah, A 2 3 and A 4 4. And we also have a 4 1, a 1 2, a 3 2 3, and a 3 4. Cool. I think that's our answer. Yeah. Any questions? What's going on? What's up in the chat? I got it wrong. There are three. A11, A32, A23, A44. This one was correct. A41, A12, A23, A34. And then the back of book. The back of the book has this one. A31, A42, A23, and A44. I don't think that's right. Okay, I remember this being weird to me. Give me a little second. Oh, little ups and downs creates a beautiful sine wave. That's a lovely phrase. I haven't heard that one before. I like that. I've never heard that. A wise soul. So don't worry about it. Oh no, I don't worry about mistakes at all. I don't give a single. I don't care, man. Like I don't care at all about making mistakes. I love mistakes. Mistakes are how you learn. Mistakes are how you get better at math. And that's why I love that this book, it's for mature mathematicians who just want to learn and get better. A wise soul, you made that on your own. You made up that quote? That's a badass quote. You are indeed a wise soul, and it's also very presumptuous to call yourself a wise soul. I love it. Welcome to the stream. Okay, so what I don't like that there's a 4 repeated. That doesn't make sense. One of those should be a 1. So I'm pretty sure that this is a typo. Pretty confident that's a typo. So let's see what happens. Let's say that the second one is a typo. And that this one should have been a 1. I remember getting 3 when I solved this on paper, and I remember seeing that this was a typo. So, I'm sorry if I'm making it seem like I'm seeing this for the first time, but I solved it differently than I just did here. I like this solution. I had an uglier solution in my notebook, but apparently it was correct. So, pretty sure that this one is correct. That this one should have been a 1, if I remember correctly. So let's be more careful because we made a mistake. That is not an inversion. An inversion is every time that a bigger number appears before a smaller number. There are 5 inversions here. There are 5 inversions. 1, 2, 3, 4, 5. Why did I miss that in my nice little algorithm? 3, 4, 2, 1. Well, I have that right here. Oh, I just miscounted it, didn't I? Which would then fix my thing that I didn't like here. So this was a hint to me that I made a mistake, and I should have followed my dreams, followed my gut instinct that there was a mistake. All right, 3, 4, 2, 1. I miscounted. I just counted it correctly a second ago. There are 5 here. 3 and 4, 3 and 2. There are 3 inversions of 3. There are 2 inversions of 4. What the? No. What am I talking about? There are 2 inversions of 3. There are 2 inversions of 4, and there's 1 inversion of 2. So I just missed one when I was writing this out earlier. Cool. Dope. There are actually 5. Let's write. Oh. There were actually 5, you knucklehead. This should have been -1. And now we have this nice, there are 3 positive and 3 negative. And then we get the other solution that we expected. Cool. Dope. So, these two together, that creates those are all 3 terms that have a negative sign in the determinant. And neat. This is great. This is delightful. I like this. This last number is literally a typo in the back of the book. Going to stay here till you say goodbye, so let's see when I get to leave in a good way, lol. Oh, okay. Sorry, I'm just catching up. Well, it is almost 11:06, so I think I am going to sleep. Enjoy your sleep. Have a nice night, dude. Thank you for tuning in. I was wanting to chat with you more, but got college tomorrow at 8 a.m., so bye. Yeah, dude, I apologize I'm taking a little long to respond to that, but have a nice night, man. Pleasant dreams. I hope you dream of math. And see you again sometime, I hope. Cheers. Nice to meet ya. All right. So, that was fun. There was Shilov. Now let's get back to Strang again. I think that I've done 9 on my own, so I want to solve one that I haven't seen yet. Okay, bye. See you soon. Yeah, see you soon. Cheers. Share with your friends. Share the stream with your friends. Let's get all our nerdy friends into the stream and hanging out and talking math together. That would be so fun. That would be sick. What's going on next? 1111. Strang. Oh no. This looks hard too. What the hell? Oh! Cool. Okay. Ha! In Strang, okay, this is an aside. Yesterday we solved Strang 1110, and it was at the bottom of the page. But then at the top of the next page, there was a pleasant little diagram. There was like a pleasant little graphics with a clock for some reason. So that was a hint. There was like a hint at the top of the next page, and I didn't see it. We solved the problem without the hint. That's cool. I don't know why there's a clock there. I haven't read it yet. 1111. So what confused me is like there's these graphics right above problem 11. So I thought that oh no. Okay, then it says problems 12 to 15 are about special vectors and cubes and clocks and figure 1-1. I take back everything I said. Never mind. It makes sense. Those diagrams should be on the same page as the problem statement, and it is, indeed. So I take it back. All right, number 11. If 3 corners of a parallelogram are 1, 1, 4, 2, Draw those parallelograms, it says. 3 corners. This sounds so boring. 1, 1, 4, 2, and 1, 3. Okay. Yeah, 1, 1, 4, 2, and 1, 3. Oh, okay. This is kind of... Okay, I think I see it. So there are other possible corners. Okay, so I see at least 2 options. So we know that... okay. I see that there can be one there. There can be one somewhere down here. There can be one over here somewhere. And it said, it gave us a hint that there are 3, so I think we're done. So let's find the values of those. So that we can see them, we're talking about this red parallelogram is created. We're talking about this one, this blue one. It's going to be a little bit more like this. And we're talking about this one. That looks geometrically, I can see that that last one is like not quite slanted correctly. Hey, it's like if you tilt your head, it's like the Triforce from Zelda. Is that what it's called? The triangles. That's probably... Hey, does a Triforce create parallelograms? Neat. I don't know if that's true. Are those parallelograms? I think that, yeah, they are. Cool. Right? I don't know if this last one is. I don't think it has to be. No, maybe it does. Whatever, doesn't matter. Let's get back to it. So there's our geometric intuition. I drew the thing and I tried to get an idea for what direction are we going to, how are we going to find these, the fourth. The fourth coordinates. So this one has like a negative x value and a positive y value. This one has a this has like the same x value as this guy, but the y value is bigger, right? And then this one has the same x value, I think. Yes, it's going to have the same x value, but the y value is less. Again, compared to that coordinate. All right, so I don't know if y'all see how I'm getting that. I think by symmetry, we are going to be expecting that this one has a smaller x value, a smaller x value, but the y value is going to be the same as that one. I think that that's what we're expecting here. But what I can see is if it's a parallelogram, we know that this is a vertical line. The x value is the same between those 2 points. It's a vertical line of length 2. So this one is going to be a vertical line of length 2. So this point 4, 2, the translation of that, one of our solutions is going to be 4, 0, as I expected. There's one of our 3. For this one, let's see. I don't want to do that one yet, because this is a similar argument. For the red one, by the same argument, but it's positive 2 instead, the y value is greater, and it's also a side length of length 2. So this one's going to be 1, 4. And here's our second solution. And now for the third one, this one is tripping me up a little bit more. How do I know? I don't think I know that y value is going to be the same. I don't think so. Like, what if we took this to an extreme and put the 3 known points? The third one is really close, instead of being relatively far. Then the corresponding one, that's going to generate this as another coordinate. And these two do not have the same y value. So I don't think that my hypothesis here was correct, that they have the same y value. Let's do that again, just to make sure. Yeah, there's no way, right? Yeah. That does not have the same y value as that. So, how else can we construct that last coordinate? I think I could do right triangles and Pythagorean theorem. Or I could probably use some sort of fact from geometry. Or we can notice that this coordinate 4, 2 compared to this coordinate 1, 3, we could calculate the slope of that, I think. And the slope, like, we can think of this as the difference of those 2 points as a vector. The vector is, the difference of those 2 points is 3 minus 1. So like to the right 3 units and then down 1. And then this slope, by definition of a parallelogram, should be equal to this slope. Right? So then, then that means that this is negative 3 units and positive 1 unit. So I can take this coordinate, which is, this is not the cleanest explanation, y'all, so sorry. Sorry, not sorry. Oh, wait. I got that backwards, didn't I? Yeah. It's like minus this number, but really I want to just see it as like 3 units to the left and 1 unit up. I think that this is the third one. I don't know. I'm just ever so slightly not confident on that last one. I think it's right. I think if I weren't on stream, I'd get like a better proof on that. But I think that's right. Let's keep going. Strang 1 1. We did 1 1 11. That was a brand new problem. I haven't seen it until now. Let's go back then. Let's do one that I did solve before, 1 1 9. And then maybe we'll call it a day at that point, because I gotta run. Yeah, you know what? It's lunchtime. I think I gotta eat. I gotta eat. My partner just arrived. Cool. Thanks everybody for joining. This is super fun for me. This is like super duper fun for me. I hope that this stream can pick up. Because I love streaming. I just think it's like really fun. Yeah. Thanks for tuning in. Please like and subscribe. Hit the notification bell so that you can see when I go live. And please leave any and all feedback. Please leave any and all feedback in the comment section if you see this someday after the fact. Thank you all. Goodbye from the horizontal stream. Hell yeah, G guy. You're the best. Thanks for tuning into the right superior stream. Cheers, y'all. Nice to see you all. And have a beautiful day. All right. Bye, everyone.